Okay, so now we're gonna do our next ratio problem, and we're gonna read it first. This is gonna be a ratio problem where we have the ratio and we have the sum, but this is more interesting because there's more involved to solving this problem, as you'll soon see. So let's read it together. Problem 5. Packages of X and Y occur in a shipment in a ratio of 3 to 4. Supposing that each package of X is 2.5 kilograms and each package of Y is 3.2 kilograms, and assuming that the shipment contains 412 kilograms of Y and a total of 238 packages, can it be concluded that the shipment was complete? So I want you to realize like how many layers there are here. First of all, we're going to have to solve the problem in terms of the ratio part, which we've done before. But then we're also going to have to do some further thinking to see whether or not we have the amount of Y we expect. And so let's begin. So first, the packages of X and Y are in the shipment are in the ratio of 3 to 4. So X, 3 to 4, Y, and Y. So in other words, we can look at the shipment in terms of groups of 7 that are like this. Okay, groups of 7. Okay. And by the way, I want to point out something I haven't pointed out in the previous problems, but I want you to notice how I draw a picture to capture what the ratio relationship is. And of course, this is not strictly necessary, but I want you to realize that I've done this intentionally because I always want you to think of a math problem or any kind of problem in everyday life in as many ways as possible. Okay, so we can see that the shipment can be grouped into groups of 7 like this because of the ratio. 3 packages of X for every 4 packages of Y, wherever X and Y are. Now they tell us that there are a total of 238 packages. Therefore, in order to find out how many groups there are, I'm going to divide 238 by 7. So I'm going to do that here. 238 divided by 7. 7 goes into 2? It does not. 7 goes into 23? Yes, 3 times. Because 3 times 7 is 21. 23 minus 21 is 2. Then I bring down my 8. Aha! 7 goes into 28 4 times. Right? Okay. And so therefore 4 times 7 is 28. And 28 minus 28, 0. So we can see the shipment consists of 34 groups. Okay? So now we can see now we can start to see how we're going to solve this problem. Now, they tell us that it contains 412 kilograms of Y. So we have 412 kilograms of Y. Right? This is part of the problem statement. We now want to ask ourselves, how much Y do we expect to have? Right? How much Y do we expect to have? Well, we know that each of these 34 groups has 1, 2, 3, 4 Y packages in each. So 34 times 1, 2, 3, 4. 4 will equal to, I'm going to do that calculation here. 34 times 4. 4 times 4 is 16. I bring down the 6 and I carry the 1. 4 times 3 is 12. I add 1, that's 13. So 136 packages of Y. 136, this is the number of packages of Y. Okay? Okay? This is how many packages of Y we have. Okay. Now I want to know how much in kilograms these packages of Y we expect to be. They tell us that each package of X is 2.5 kilograms and each package of Y is 3.2 kilograms. Aha. So 136 times 3.2, this is going to be the amount of Y we expect to be on this shipment. Okay, let me multiply that over here. 136 times 3.2. Multiply. 2 times 6 is 12, so I bring down the 2, carry the 1. 2 times 3 is 6, 7. 2 times 1 is 2. Then I'm going to do 3 times 6 is 18. I'm going to bring down the 8, carry the 1. 3 times 3 is 9. I add 1, that's 10. So I'm going to bring down the 0, carry the 1. 3 times 1 is 3, plus 1 is 4. Now I'm going to add this. 2 comes down. 7 plus 8, that's 15. I'm going to put the 5 down and I'm going to carry the 1. 1 plus 2 is 3. 3 plus 0 is 3. And then I bring down the 4. There's only one decimal place. So there's only one decimal place in the solution going from the left. Okay? Okay. So that's going to be 435.2. This is the kilograms of Y that we expect. Okay. And forgive me about this multiplication that it ended up like so awful, but yes. Okay. So look at this. So we now know that we should expect 435.2 kilograms of Y in the shipment. But we have 412 kilograms of Y. Okay? So we can immediately conclude that the shipment is not complete because there's 435.2 kilograms that we expect, but we have only recovered 412 kilograms. So somewhere that difference got lost. We can even though it's not necessary for this problem because we only wanted to know if it was complete, I want to briefly calculate how much is missing because that could also be what the question might have asked in a different situation. Okay, so I'm going to do 435.2 minus 412. So here, I don't have a decimal here, so I can just put 0.0. 2 minus 0 is 2. I bring down my decimal point. You notice when I'm subtracting or adding decimals, I line the decimals up. 5 minus 2 is 3. 3 minus 1 is 2. And then the 4 minus 4 is 0. So we are missing 23.2 kilograms of Y. Okay? So now I want to make a few more comments about this problem. Okay? Now, some of you might have noticed something about this problem when we first finished reading it. And you guys might have thought right away, well, we don't know anything about the quantity of X that was recovered. How will we be able to make any conclusion about whether the shipment is complete or not? So that would have been one thing that you might have thought of. And that would be a very valid point. If we had indeed, under that consideration, if we had indeed discovered that 412 kilograms was what we expected and 412 was what we recovered, then we could say that the shipment was complete in terms of the Y, but not knowing how much X was recovered, we would not be able to say whether the shipment is complete or not because we don't know how much X was recovered, even though we can calculate how much X we could expect. So that would have been one consideration. But in fact, we found here that the shipment was not complete with respect to y. So we could in fact reach a conclusion, regardless of what the situation was with the x, that in fact the shipment was not complete. Moreover, we were able to discover how much was missing. 23.2 kilograms of y were missing. And also I want you to notice how this problem required us to do several different layers of calculation, as most real life problems are going to require. First, we had to determine, using the ratio, how many packages of y there were. Then, using the weight of each package, we had to find out how much the weight of all those packages would be. And then we had to compare that to what we were given. And then we were able to determine that we were short. Now, I also want to point out something else about this problem. I want you to notice that the problem includes the weight of each package of X, 2.5 kilograms, but it was never used in the course of this problem. And moreover, the problem, as we mentioned just a moment ago, does not include how much X was recovered. So you can see this 2.5 as extra information that's not necessary to solve this problem. And also we can look at the other information I just mentioned, how much X was recovered, as missing information if it was a real life situation where we did want to find out whether or not the X was complete or not. I hope that this problem has helped to make you more excited about this topic and how you can rapidly build up on the sophistication of the problems that you can solve with these techniques. Thank you, and I'll see you again soon. Goodbye.